Hello everyone, I'm Jivika Kancherla and I'll be explaining you guys the solving of ninth question in homework 8 of the course Probability and Stochastic Processes. Before we go into looking for the solving, let's have a quick look at the question. Show that if x1, x2 and so on xn is a Markov chain, then it is statistically determined by its second order probability masses. That is p of xi is equal to xi, xj is equal to xj for any ij equals to 1, 2. So let's look at the solving for this question. In this question, we are asked to show that if x1 and x2 is a Markov chain, then it is statistically determined by its second order probability masses, that is p of xi equals to xi, p of xj equals to xj for any positive integers of ij. That is, it is given that I comma j is equal to 1 to n, so it is only going to take for positive values. In other words, we are asked to find or prove that the joint probability of xi equals to xi for each term. Now, we know that the joint probability will be solely determined by a function of probability masses, that is the second order probability masses. So let's have a quick look at it. So this will be our equation, that is p of x1 equals to x1, x2 equals to x2 and so on, xn is equal to xn. So we can use the basic rules and expand this as the probability into a product of the conditional probability times the probability of the condition. That is, since it is a conditional probability, it will be the product of the conditional probability times the product of the condition. That is, this is the condition, this is the conditional probability. Therefore, p of x1 equals to x1, x2 equals to x2 and so on, xn equals to xn can be written as the probability of xn equals to n given xn minus 1 equals to xn minus 1, xn minus 2 is equal to xn minus 2 and so on till x1 is equal to x1 times the condition, that is this one, this part, that is probability of xn minus 1 is equal to xn minus 1, xn minus 2 is equal to xn minus 2, xn minus 3 is equal to xn minus 3 and so on till x2 is equal to x2 and x1 is equal to x1. So we see that the probability of xn will be equal to xn for all the states given before that. That is, xn is equal to xn, which means that it is equal to all the states before it. Therefore, this can be, this second term, that is xn minus 1 equals to xn minus 1, can be rewritten in the same form as the above equation as we have seen. That is, we've written x1 is equal to x1, x2 is equal to x2 as xn minus n, xn is equals to n given xn minus 1 equal to xn minus 1 and so on. Therefore, we will write probability of xn minus 1 is equal to xn minus 1 so on till x1 is equal to 1 in terms of probability of xn minus 1 equal to xn minus 1 given xn minus 2 is equal to xn minus 2 and so on till x1 is equal to x1, and this condition, that is probability of x2 is equal to x2 given x1 is equal to x1 and so on, it will come till probability of x1 is equal to x1. Therefore, this term can be represented simply as, that is, probability of xi is equal to xi is equal to the summation k is equal to minus infinity to infinity probability of xi is equal to xi comma xj is equal to k. Now, since we know that the probability of uh, uh, second order probability masses can be written as probability of xi equals to xi given xi minus 1 is equal to xi minus 1 as the probability of xi is equal to xi comma dot xi minus 1 equals to xi minus 1 by probability of xi minus 1 equal to xi minus 1. Therefore, this proves that x1, x2 is a Markov chain, that it is statistically determined by its second order probability masses where p of xi equals to xi and xj equals to xj for any positive integer I comma j is equal to 1 to n. Therefore, this is the solving of ninth question.